Scientists are currently grappling with a discovery that suggests a massive and sudden disappearance of matter on a cosmic scale, an event that seems to defy the established principles of physics. At the heart of this enigma is the James Webb Space Telescope, an instrument so powerful that it has been likened to a time machine, peering deep into the past by capturing the faintest light from the most distant corners of the universe. After only a couple of years in operation, the James Webb Space Telescope has delivered data that is rewriting what we thought we knew about space. Among its most shocking revelations is the apparent vanishing of over 900 trillion stars that were once catalogued, visible, and measurable through our instruments, but now seem to have ceased to exist without leaving any trace. This finding is not only perplexing but deeply unsettling. How could so many stars simply disappear? Where did they go? And what force could have caused this phenomenon? One theory suggests that these stars have not truly vanished, but have simply become invisible to our current methods of detection. It's possible that they underwent processes which dramatically dimmed their brightness, perhaps by collapsing directly into black holes without the explosive spectacle of a supernova. Alternatively, they could be obscured by immense clouds of cosmic dust, blocking their light from reaching us. But there's another possibility, one far more disturbing. What if these stars have truly ceased to exist? What if the universe itself is undergoing a fundamental transformation that we are only just beginning to detect? To understand the scope of this mystery, it's important to revisit our understanding of the universe's expansion. Nearly a century ago, astronomers discovered that distant galaxies were moving away from us, leading to the theory that the universe is expanding. Initially, this expansion was thought to be slowing down due to gravity. However, in the late 1990s, scientists made an astonishing discovery. Not only is the universe expanding, but this expansion is accelerating. The farther away a galaxy is, the faster it seems to be receding. This observation led to the concept of dark energy, a mysterious force that makes up roughly 68% of the universe and drives its accelerating expansion. But now, the new data from the James Webb Telescope is challenging this narrative. It has observed distant galaxies and star systems that appear inconsistent with the expected patterns of expansion. Some regions of the universe are not just expanding, they seem to be dissolving, with celestial objects fading out of existence. This is more than just redshifted light. It's as if chunks of the cosmos are retreating into an unreachable domain or simply being erased from existence. The redshift, long used as the gold standard for measuring distance and velocity in cosmology, is no longer behaving predictably. Instead, Webb has captured wavelengths that suggest entire clusters are vanishing or accelerating beyond theoretical expectations. This new evidence has led some scientists to question whether the Big Bang theory, long the dominant explanation for the origin of the universe, is complete or even correct. The Big Bang model explains that all matter in the universe originated from a single, infinitely dense point, expanding outward to form galaxies, stars, and planets. But if enormous quantities of matter can simply disappear, perhaps our understanding of space, time, and the evolution of the cosmos is fundamentally flawed. Could we be witnessing a new phase of cosmic evolution? Could the universe be preparing for a massive transformation or even a contraction after billions of years of expansion? What's particularly striking is the way James Webb is able to peer into the early universe, back to a time only a few 100 million years after the Big Bang. Through this cosmic window, it has captured images of galaxies that shouldn't exist yet, at least not by our current models. These galaxies appear too mature, too large, and too well-formed to have developed so early in cosmic history. This further complicates the picture, suggesting that the universe may have had a different developmental timeline than previously thought. Perhaps it formed structures much faster, or perhaps it is much older than we believe. In either case, the implications are enormous. The disappearance of 900 trillion stars cannot be ignored or dismissed as an observational error. Webb's instruments are precise, and its ability to detect the faintest glimmers of light from billions of light-years away has been thoroughly validated. This forces us to consider more speculative possibilities. Are we observing a breakdown of physical laws in distant regions of the universe? Could unknown forces, perhaps tied to dark matter or quantum fluctuations on a cosmic scale, be actively reshaping space itself? Adding to the mystery is the fact that many of these missing stars resided in galaxies that appeared to be relatively stable. There was no indication of cataclysmic events or widespread collapse. Their sudden absence leaves behind dark voids, silent testimony to something profound and unexplained. Scientists are now racing to gather more data, to compare past observations with new ones, and to explore whether this disappearance is a localized phenomenon or part of a larger pattern unfolding across the universe. If this vanishing act continues or accelerates, we could be looking at an existential turning point in our understanding of reality. The idea that large sections of the cosmos can blink out without warning challenges everything from astrophysics to quantum mechanics. It may even raise questions about the fabric of time itself. Could we be witnessing the early stages of a universal reset? A loop? A cyclical birth and rebirth of cosmic structures? Or something stranger still, a transition to a parallel state of being? What we do know is that the James Webb Space Telescope is pulling back the curtain on a drama more complex and thrilling than we could have imagined. Each new observation it sends back is not just a snapshot of distant galaxies, but a clue to our place in a grand, unfolding narrative of the universe. And while we may not have all the answers yet, one thing is certain. The universe still holds secrets that could reshape everything we think we know. As we continue to search the skies, guided by light that has traveled for billions of years, we may be on the verge of discovering truths that are not just cosmic, but eternal. In the vast expanse of space, the universe continues its silent expansion, driven by forces we are only beginning to understand. Observations of how galaxies move and how space itself stretches have given scientists the ability to estimate the makeup of our universe. Roughly 68% of it consists of dark energy, an invisible force acting in opposition to gravity. About 27% is dark matter, a mysterious substance that doesn't emit, absorb, or reflect light, but whose gravitational pull we can detect. That leaves only about 4.9% of the universe made up of the familiar particles, protons, neutrons, and electrons, that form everything we see. A mere fraction, around 0.1%, is made of neutrinos and antineutrinos, and just 0.08% consists of photons. The very light that allows us to observe the cosmos. With this detailed understanding of the universe's ingredients, physicists apply Einstein's general theory of relativity to predict the future of everything that exists. What emerges is an astonishing revelation. The universe is not just expanding, it's accelerating. Galaxies that aren't gravitationally bound to us are moving away faster and faster, and this acceleration is driven by dark energy. This means that as time goes on, galaxies will grow more distant, not just physically but in terms of visibility. Eventually, the very fabric of space between us and those galaxies will stretch so much that light emitted by them will never reach Earth. Even if a photon starts its journey from one of these galaxies right now, the space it must travel is expanding faster than it can move. This leads to a chilling consequence. While we might think of the speed of light as the ultimate cosmic speed limit, the expansion of space itself breaks that limit. Distant galaxies will eventually recede so quickly from our point of view that no signal or spacecraft, no matter how fast, could ever reach them, or return. They're not moving through space. Space itself is expanding between us and them. While some of these galaxies are only 18 billion light-years away, the relentless acceleration means their light will never again cross the void to reach our telescopes. They're effectively gone. The observable universe currently spans about 46 billion light-years in every direction. But even within that massive sphere, only a small portion of the universe remains accessible to us. In fact, estimates suggest that just 6% of all galaxies are still within our cosmic reach. That means 94% are already too far to ever visit or even see again once their light fades beyond detection. This isn't due to technology, distance, or speed, but to time. Every passing second seals more of the cosmos off from us forever. It's hard to comprehend that 20,000 to 60,000 stars slip out of our reach each and every second. The light they emitted a moment ago will eventually arrive here. But the light they emit now, in this instant, never will. This reality offers a sobering perspective. Our ability to explore or even observe much of the universe is fleeting. Time itself is closing the window on our cosmic neighborhood. Every moment we wait is a moment lost, one more galaxy moved beyond the edge of our sight. If humanity ever wishes to venture beyond the Milky Way and our local group, which includes Andromeda and around 60 smaller satellite galaxies, we are racing against a clock we cannot see, and cannot stop. The longer we wait, the smaller our future becomes. There are about 2 trillion galaxies scattered throughout the known universe, each filled with stars, planets, and potentially even life. And yet, due to dark energy's accelerated push, the overwhelming majority, 94%, are now permanently unreachable. This isn't speculation. It's a scientific certainty. Unless we develop unprecedented technologies that allow us to leap between galaxy clusters or bend space-time itself, the vast majority of the universe will remain forever out of reach. Messages sent to those far-off regions will fade into silence, unanswered and unheard. Civilizations, if they exist out there, may never know we're here. And we may never know them. The expansion of the universe is not something we can fight. It's built into the structure of space itself. Our gravity, no matter how cleverly we harness it, cannot overcome the relentless march of dark energy. It pulls the cosmos apart at the seams. We are left with 2 choices, act or accept. Venture outward with everything we have, or remain in our local galactic neighborhood until, one day, even the stars close by will fade from view. And then, even if life survives, the universe around it will grow colder, darker, and lonelier. In this ever-expanding reality, every second counts. Every delay in our quest for exploration narrows the possibilities for discovery. We live in a small window of time when the universe is not yet too vast to reach out to. The stars are still speaking to us. The galaxies are still shining. But that won't always be true. Eventually, only the echo of their light will remain, frozen in time, unreachable, a memory of what once was. And in that thought lies both the tragedy and the beauty of our existence. The tragedy is that we are limited. The beauty is that we are aware. We can choose to observe, to reach, to understand, while we still can't. There is nothing we can do to stop the universe from expanding, but we can make the most of what remains within reach. Every signal we send, every telescope we build, every journey we embark on becomes part of a grand cosmic story, one written in the stars and carried on the wind of time itself. Let us not waste that opportunity.